Hello students, let us begin the lecture number 3, which is about the concept of electrophiles and nucleophiles. So let us start discussing about electrophiles. Now in organic compounds there are covalent bonds, and there is unequal sharing of these electrons in a covalent bond only when different atoms form that bond. And this unequal sharing is mostly due to the differences in the electronegativity between the two atoms which form the bond. For example, let us take hydrogen chloride or HCl. This has a bond covalent. This has a bond between H and Cl, but there is a large electronegativity difference between the hydrogen and the chlorine on the Pauling scale of electronegativity, about which you can learn in greater details here by going to the electronegativity page on Wikipedia. But coming back to the HCl molecule, the hydrogen has a electronegativity of 2.2 and chlorine has a electronegativity of 3.16. Therefore, there is a large difference between the electronegativity of these two atoms, and as a result, HCl bond is a polar bond where partial positive charge is located on the hydrogen and partial negative charge is located on the chlorine atom. Therefore, hydrogen atom has a lesser share of electrons than it will have in dihydrogen. That is, when the hydrogen is part of a H2 molecule, it is having an equal share of these bonding electrons. But in HCl, it gets a lesser share due to the electron withdrawal by the more electronegative chlorine atom. Thus, we can see that hydrogen atom in HCl molecule is electron deficient. Because of this electron deficiency, hydrogen atom in HCl is looking for electron shares which has been taken by the chlorine atom. So that is therefore HCl hydrogen in HCl will react with any reagent having an excess electron density like hydroxide ion or even a pi electrons of the carbon-carbon double bond will supply this electron density to the hydrogen atom, electron deficient hydrogen atom in the HCl. And therefore, we say that hydrogen in HCl is electrophilic. You must remember from last semester that we studied electrophilic addition of HCl or HBr to alkenes, and this addition is called electrophilic because hydrogen is adding as an electrophile. Now let us see some of the examples of electrophiles. The organic molecule benzyl chloride has a polar carbon chlorine bond. Again, by taking reference of the electronegativity values on the Pauling scale, carbon has electronegativity value of 2.55, whereas chlorine has a electronegativity value of 3.16. Because of this electronegativity difference, you will see that in the benzyl chloride molecule, there is a partial positive charge on the carbon and partial negative charge on the chlorine atom. And thus carbon atom has a lesser share of electrons. Therefore, carbon atom in the benzyl chloride will react with an electron rich center. Again, for example, sodium hydroxide or sodium methoxide. The oxygen atom in both these molecules is the electron rich center. Now, if you allow these molecules, that is sodium methoxide and benzyl bromide, to react, the electrophile will be attacked by the nucleophilic oxygen atom, and the bromine will be kicked out from the molecule, and it will give you an ether. This typical SN2 reaction we have studied in the last semester. Now let us quickly look at what are nucleophiles. Nucleophiles are molecular species with electron-rich regions, usually atoms or groups. That means they have, here are some of the examples like water molecule, ammonia, H2S and phosphine. All these compounds contain atoms which have extra electron density on them. Oxygen has two lone pairs in water, In ammonia, the nitrogen has one lone pair. Again, in H2S, sulfur has two lone pairs. And in phosphine, phosphorus has one lone pair of electrons on the phosphorus atom. And therefore, these molecules are nucleophiles and they react with other molecules or atoms to donate this extra electron density. Mostly species with lone pairs of electrons like water, ammonia, or any other molecules containing oxygen, nitrogen, sulfur, phosphorus uh, will act as nucleophiles under right conditions. Some more examples can be seen here where water, methanol, or any alcohol, or ether, or phenols for that matter, all contain oxygen atom with two lone pairs of electrons. Therefore, they behave like nucleophiles. And similarly, nitrogen containing compounds like ammonia, methylamine, any of the primary amines or even secondary and tertiary amines all contain one lone pair on the nitrogen atom and therefore they behave like nucleophiles. Similarly, compounds containing sulfur like methane thiol, alkyl thiols, or the thioethers, or the uh, thiophenol all contain lone pair on the sulfur atom and they will also behave like nucleophiles. But in addition to this, there are some carbon containing compounds which may also act like nucleophiles. The examples are the classical HCN, also known as hydrogen cyanide, and here you can see because of the electronegativity difference between the hydrogen and carbon, the carbon is getting a partial negative charge because of which it is able to act like a nucleophile. Similarly, in other reagents like the Grignard reagent RMgX that we have studied earlier, the magnesium is having a partial positive charge and the carbon is having a partial negative charge. Because of this partial negative charge, these Grignard reagents have the ability to act as nucleophiles. Then there are other examples which we have briefly touched in the last semester are also good examples of nucleophiles, carbon containing nucleophiles. Then can you identify the following compounds and classify them as either electrophiles and nucleophiles? Sodium hydroxide is a nucleophile. Potassium fluoride is a nucleophile because fluorine atom being a small in size has a larger share of negative charge on it and therefore it acts as a nucleophile. Similarly, methyl iodide has a carbon iodine bond because of the electronegativity difference. The carbon has a partial positive charge, and it acts like an electrophile. Benzyl bromide similarly is an electrophile. CO2, formaldehyde, and acetophenone are all examples of electrophiles. Now I leave this assignment for you to identify these structures and identify which are the electrophilic species and which are the nucleophilic species. And we will do some more examples in the classroom. Our next lecture will be on benzene and aromaticity. So see you then. Thank you.